All right, so we're in section 14.6. We are going to talk about the inverse of a square matrix. All right, so an inverse is a matrix that it's needed for, like, quote unquote dividing. And we can only do inverses of square matrix. And so what's a square matrix? A square matrix is a matrix with the same number of rows and columns. The identity matrix, okay, the identity matrix is the special matrix with ones along the diagonal, so that would be all down from top left to bottom right, and then zeros everywhere else. And we've sort of seen this matrix a little bit as we were playing with solving systems of equations. If you got the identity matrix, then the answer was in the augmented side. Okay, so this is the 3 by 3 identity matrix, and the 2 by 2 identity matrix would be 1, 0, 0, 1, and so on and so forth. So there are lots of different identity matrices, just one for each order. Okay, so let's talk about what the inverse is. Now, the inverse of a matrix is a matrix of the same dimension, okay, so it'll be a 3 by 3, so that when you multiply these two matrices together, you get the identity matrix. And so, for example, if A is a 3 by 3 and B is a 3 by 3, and you multiply those together and you get the identity matrix, then they are inverse matrices of each other. And the analog in numbers would be like 2 and 1/2. These are inverse numbers, right? 2 and 1/2 are inverse numbers because when you multiply 2 times 1/2, you get 1. And so the same kind of thing is happening here with matrices. And so I have here an example of two 3 by 3 matrices, and I'm claiming to you that these are inverse matrices. And so to show that these are inverses, I'm going to do A times B, and I'm going to see what I get here. So if I do A times B, I have 2 minus 34 plus 33. So that would be 2 minus 1, which is 1. And now I'm going to take row 1 by column 2, and I get 2 minus, I don't know what 17 times 4 is, 68. So 2 minus 68 is negative 66 times plus 66, 11 times 6. So that's 0. So I took row 1 times column 2, that's going to go there. And now row 1 times column 3 will give me 4 plus 3 times 17, which is 51. So 4 plus 51 is 55, minus 55 is 0. Okay, now moving on to row 2, negative 1 plus 22 is 20. Hold on, what am I doing there? Yeah, row 1, column 1. So negative 1 plus 22 minus 21. Yes, that's 0. Negative 1 plus 44 minus 42. Yes, is 1. And then negative 2 times 1 is negative 2, minus 33, minus 35. Hold on, no, plus 35. Negative 2 minus 33 plus 35 is 0. Okay, and then the last row, oh, that's nice. The 0 is wonderful. So 3 times 2, that's 0. 12 minus 12, and then negative 9 plus 10 is 1. And so, yes, that's the identity matrix. Now, we also have to check B times A, and you have to see if that is the identity matrix. And so to do B times A, now we're going to take the rows in B and multiply by the columns in A. Because matrix multiplication is not commutative. It could be a different matrix the other way. And so if I take 1 times 1, or 1, 1, 2 times 2 dotted with 2, negative 1, 0, I get 2 minus 1. And now I'll do it to the row 1 to the second column. I get negative 17 plus 11 plus 6, that's 0. And then to the third column, I get 11 minus 7 minus 2, that's 0. Minus 4, that's 0. Okay, and then now I'm going to take row 2 times column 1. 4 minus 4, 0. Negative 34 plus 44, so that's 11, minus 9, hold on. Negative 34 plus 44, oh, that's 10, minus 9 is 1. Okay, and then row 2, column 3 is going to be 22 minus 28 plus 6. Okay, and then last one, last row, row times column 1, I get 6 minus 6, and then I get negative 51 plus 66 minus 15. That's 0. And then 33 minus 42 plus 10 is 1. Okay, that's a, yeah. Okay, and so yes, these are inverse matrices of each other. Gosh, just the multiplication was hard, and I actually gave you the inverse matrix. And so, of course, the next thing we're going to have to do, what do we want to do? I want you to find the inverse of a matrix. And so how do you find the inverse of a square matrix? Well, we're going to do 2 examples. I'm going to show you a shortcut, and I'm going to show you how we use it. All right, so to do that, we're going to write the given matrix, augment it with the identity matrix for that particular size matrix. And then we're going to do row reductions, just like we did when we were solving systems of equations. Same thing. And you're going to do that on the entire augmented matrices so that you get the identity matrix on the left. And then you're going to mess up your other identity matrix on the right. That's good. That's the inverse. Okay, so let's start with this example 1. So I'm going to take my matrix A, 2, negative 17, 11, and I'm going to augment this with the identity matrix. And so it's just like the augmented matrices when we had systems of equations, but on the right side, instead of a 3 by 1, we have a 3 by 3. And what I'm going to do is I eventually want this matrix over here to look like the identity. I want it to have 1s on the diagonals and 0s everywhere else. Just like when we were solving systems of equations, we had to eliminate things. Okay, so I'm going to start out by not changing my first row. Well, it would be, yeah, 2, negative 17, 11, 1, 0, 0. I'm going to change this negative 1 into a 0 by taking row 1 plus 2 times row 2, and that's my new row 2. So negative 17 plus 22 is 5. And then 11 minus 14 is negative 3. And then 1 minus 0 is 0, 0, or plus. 1 plus, and then 0 plus 2 is 2. 0 plus 0 is 0. Now my bottom row, I don't have to do anything to because it already had a 0. Yay. All right, so now I've got my zeros here. That's good. Now let's get my zeros here in column 2 and there in column 2. Oh, I have a 17 and a 15. Okay, so in order to make this negative 17 into a 0, I'm going to do 17 times row 2 plus 5 times row 1, and that's my new row 1. So I'm not changing my row 2. I'm going to rewrite this. Okay, so in row 1, I'm going to get 5 times 2 is 10 plus 0. And then I don't even know what those are, but they're going to be 0. 55 minus 3 times 17. 3 times 17, that was negative 51. So that's 4. Then 5 and 17, that's 22 here. And 0 plus 34. And then 0 plus 0. All right, now let's change my bottom row. To do my bottom row, I'll do that in blue. I'm going to do negative 3 times row 2 plus 5 times row 3, and that's my new row 3. Okay, so then that'll give me 0 plus 0 here. Negative 15 plus 15 is 0 here. 9 minus 10 is negative 1. Negative 3 plus 0. Negative 6 plus 0. And then 0 plus 5. Okay, moving along. Now I've got my zeros in my column 2 like I want. Now I'm going to get the zeros in my column 3. Okay, so let's go ahead and negate this. So I'm going to drop these negatives and negate that one. So 0, 0, 1, 3, 6, 5. Okay, so to get rid of the negative 3 here, I'm going to take 3 times row 3 and add it to row 2. So I get 0, 5, 0, 10. 3 times 6 plus 2 is 20. And then 3 times negative 5 is negative 15. And now to get rid of the 4 in the row 1, I'm going to need to multiply row 3 by negative 4 and then add. So 10 plus 0 is 10, 0 plus 0 is 0, 4 plus negative 4 is 0, 22 minus 12 is 10, 34 minus 24 is 10, and 0 plus 20 is 20. So it's looking like these are going to reduce very nicely. Now I can get my ones. So the bottom row was good. It already had a 1. And now in my second row, I just need to divide by 5. So that's 2, 4, negative 3. And then in my top row, I just need to divide by 10. So 1, 0, 0, 1, 1, 2. Okay, so I got the identity matrix on the left. This matrix here on the right is the inverse matrix. So the inverse matrix, we write that as A inverse. That is 1, 1, 2, 2, 4, negative 3, 3, 6, 5. And I want you to check. I want you to tell me what A times A inverse is. We'll just check one time. And you can do that on your own. And tell me if that is, if you got the identity. So check to see if I got it right. All right. The second example is going to be much simpler. It is a 2 by 2, so it's easier. It's less work. I'm going to pull it down here. Okay. So example 2, and you're going to check that. All right, so we have a 2 by 2, and it's 2, 3, 1, 4. I'm going to augment that with the 2 by 2 identity matrix. Now I'm going to do row operations until the left side looks like the identity. All right, so let's just switch these. 1, 4, 0, 1. And now let's do negative 2 times this row, add it to this row, and that's my new bottom row. So that'd be negative 8 plus 3 is negative 5. 0 plus 1 is 1, and then negative 2. Did I do that right? Yeah. Okay. And then I'm going to have to do 5 times row 1 plus 4 times row 2, and that's my new row 1. So I'm not changing this bottom row. And so then I get 5 here, 0 here, 4, and 5 and negative 8 is negative 3. Okay, and now it looks like I need to divide by 5 in row 1. 4/5, negative 3/5. So it's not a pretty one this time. And negative 5 in row 2. So 0, 1, negative 1/5, 2/5. And so here my identity matrix, or sorry, yeah, my inverse matrix is the matrix 4/5, negative 3/5, negative 1/5, and 2/5. Okay, so, and I can check that actually really simply because I know the shortcut. The original was 2, 3, 1, 4. I don't think, well, I don't know. Let's see here. Okay, so here's the formula for how you do the, right, how you do the inverse of a 2 by 2. And it's really simple to do. You just switch the A and the D, and you negate the A and B. And so on this matrix we just did, so that would be 4, 2, negative 3, 1. And then you also divide by a special number. The special number is AD minus BC. You multiply here and then multiply here and subtract. AD minus BC. And so AD is 8 minus 3 is 5. So 1/5. That's where that 1/5 came from. Oh, this should be negated. And so did we get, it looked like that. Did we get 4/5, negative 3/5, negative 1/5, 2/5? If not, then find my mistake for me. Okay, so let's do this next inverse because it's really simple. So 2 times 9 is 18 minus negative 18. So plus 18, that's 36. So it's going to be 1 over 36. And then you switch the 9 and 2. And then you It's the negative of the B and C spots. And that's it. So it's much easier for 2 by 2s. Unfortunately, there's no simple formula for 3 by 3s. All right, back to systems of linear equations. Yay! So whenever you have a system of linear equations like we do on this one, you can solve this by augmenting and then performing the row reductions. That is the same thing that we do when we find the inverse matrix. And so if you look at this equation here, A times X equals B, when these are matrices, the matrix X is solved by doing the inverse of A times B. And so this system of equations here, okay, if I make A the coefficient matrix, 2, negative 17, negative 11, negative 1, 11, negative 7, 0, 3, negative 2, and then X is the matrix X, Y, Z. And then my B matrix is the answer matrix. That would be 1, negative 1, 1. Notice that if you perform matrix up multiplication, you get exactly this equation because A is a 3 by 3, X is a 3 by 1, and your answer then is a 3 by 1, and it equals this answer matrix. Okay, so what is A inverse? Well, I believe this was the example, the very first example question. And if you look back at the notes there, which we already did this, the inverse matrix was 1, 2, 3, 1, 4, 6, 2, negative 3, negative 5. And so that's my inverse matrix. If you multiply A inverse times B, you will get the answer. So I'm going to take A inverse and I'm going to multiply that to B, the equal side of the matrix. And when I do that, matrix multiplication here, then I get my answer, the XYZ matrix, is, so I'm just doing matrix multiplication. I'm going to take row 1 times this column. So I get 1 minus 1 plus 2. And then I get 2 minus 4 minus 3. And then I get 3 minus 6 minus 5. Right? Yeah. And so that's the answer. 2, negative 5, negative 8. And you can check that on the calculator if you want. This is another reason why we learn inverse matrices. And we're all done.